Sangita Purkait, Assistant Professor of Sangita Institute of Science and Technology. Today I am going to discuss how to prove the inequality by Lagrange mean value theorem. This MVT means mean value theorem. This is very important topic for your examination. Actually, this is the part of your BTech syllabus first year, first semester. Now, first of all, we will see what is the statement of Lagrange mean value theorem. Number one is, let fx is any function which is defined on closed interval a comma b. This third bracket of a comma b means closed interval a comma b. Now, statement number one is, fx is continuous for all. This sign is called for all. Fx is continuous for all x belongs to. This sign is called for all and this sign is called belongs to. Closed interval a comma b. Now statement number 2. Fx is derivable. What is the meaning of this derivable? Derivable means the derivative of f dash x exists. Derivative of fx will be exist for all x belongs to open interval a b. You see, this is the third bracket of a comma b. This means closed interval a comma b, and first bracket of a comma b means open interval a comma b. Now, if these two conditions are satisfied by our function fx, then only we can say that the function satisfies Lagrange mean value theorem, and then there exists, this sign is called there exist. Then there exists at least one value c. C belongs to open interval a comma b such that f of b minus f of a by b minus a equal to f dash c. This is the conclusion of Lagrange mean value theorem. This is the conclusion of Lagrange. Okay, this is the conclusion of Lagrange mean value theorem, and we can get only the value of c only when the function satisfies these two conditions. If the function does not satisfy any one of these two conditions, then we cannot get the value of c. Okay? Now, how to prove the inequality? For finding the inequality, we have the another form of Lagrange mean value theorem. What is the another form? In another form, we will put b equal to a plus h and c equal to a plus theta h. What is theta? Theta is a number which lies between 0 to 1. Now, this is equation number 1. This conclusion is equation number 1. Then from 1, we will put b equal to a plus h and c equal to a plus theta h. F of b will be f of a plus h minus f of a divided by b minus a. B means a plus h minus a equal to f dash c. C value a plus theta h. Okay. Now plus minus a cancel. So f of a plus h minus f of a will be h into f dash a plus theta h. Okay. So f of a plus h will be f of a plus h into f dash a plus theta h. Now from this equation, if we put small a equal to 0, we will get a formula which is called Maclaurin's formula. So in another form of, this is the another form of Lagrange mean value theorem, and if in this form, if we put small a equal to 0, we can get a formula which is called Maclaurin's formula. Now what is the formula? F of h equal to f of 0 plus h into f dash theta h. Okay. Now since your question paper there will be fx is our function, so we can rewrite this formula by taking h equal to x. So the final Maclaurin's formula is f of x equal to f of 0 plus x into f dash theta x. We just put h equal equal to x in this formula. Since your question paper there will be fx. Now this is the final formula of, let this is equation 3. This is the final formula of Maclaurin's formula, which we can derive from Lagrange mean value theorem. Okay, from Lagrange mean value theorem we can derive from, this is the conclusion of Lagrange mean value theorem, this is the another form of Lagrange mean value theorem, and in this another form if we put small a equal to 0 we can get this Maclaurin's formula. Now by using this Maclaurin's formula we can prove the inequality. Let us take an example of an inequality. Prove that x less than log of, x by 1 plus x less than log 1 plus x less than x. Okay, now we will prove this by using this Maclaurin's formula. Okay, now you can see that this Maclaurin's formula actually depending on our fx. Left hand side is fx, and if we get fx then we can find f of 0. If we get fx then we can find f dash theta x. So this entire formula is depending on our function. So first, for proving this inequality we have to choose our function. Now you can see that this log of 1 plus x is our main function, which is greater than one function and less than one function. Okay, so we can calculate or we can choose fx is log 1 plus x. Okay, now first we will find what is f of 0. F of 0 is log 1 plus 0, that is log 1, and we all know log 1 is 0. Next we find f dash theta x. So first we have to find f dash x. What is f dash x? If we derivative log, then we will know that the value will be 1 by something. So log of x, derivative of log x is 1 by x. So derivative of log 1 plus x will be 1 by 1 plus x. Now what is f dash theta x? We will put theta in place of x, then f dash x change into f dash theta x. So that will be 1 by 1 plus theta x. Now we will put these two values in this Maclaurin's formula. So from 3 we can get fx. What is fx? Fx is log 1 plus x. Log 1 plus x equal to, what is f of 0? F of 0 is 0. So that is 0. X into f dash theta x. F dash theta x is 1 by 1 plus theta x. So ultimately by using Maclaurin's formula, log 1 plus x is x by 1 plus theta x. You can see that x into x, f dash theta x is 1 by 1 plus theta x. So this is ultimately x by 1 plus theta x. So after applying Maclaurin's formula, we get our value is x by 1 plus theta x. Now we have to prove, this is an equation, but we have to prove this inequality. So from equation, how to get inequality? From equation how we can calculate the inequality. So we can do one thing, we can take an help of inequality, and in this entire page you can see that we have only one inequality, which is theta's inequality. So we can take this help of this theta's inequality. So now from theta's this inequality we can prove this value. Okay, now we know that theta is greater than 0 less than 1. Now what is here? It is theta x. So step by step we can calculate the inequality. First we multiply both sides x. So theta into x. So 0 into x will be 0. 1 into x will be x. Next it is 1 plus theta x. So we are taking 1 all side. Okay. So that is converted into 1 less than 1 plus theta x, less than 1 plus x. Then 1 plus theta x is in denominator. So we can take this all 1 by, and if we 1 by, then the inequality will be interchanged. Why? Because we know 2 is less than 3. We all know that 2 is less than 3. But if we take 1 by 2, we cannot write 1 by 2 less than 1 by 3. Then we have to write 1 greater than 1 by 3. So if we take 1 by of any number or function, then the inequality will be less than to greater than. Inequality will be interchanged. Now if we take 1 by of this all function, then that will be this side and 1 will be this side. So that will be 1 by 1 plus x less than 1 by 1 plus theta x less than 1. Okay, next the denominator the numerator is x. So we can take all numerator is x. So that is converted into this. Okay, x by this and 1 into x is this. Now you can see that what is our proof? This both sides, and now we have the both sides are all same, and this is equal to, we know this is our log 1 plus x. Sorry, this is our log 1 plus x. So finally we can write x by 1 plus x less than log 1 plus x less than x. So this is our proof. So we can prove this inequality by actually we can prove this inequality by using Maclaurin's formula, but Maclaurin's formula is derived from Lagrange mean value theorem. The question was something that they prove this inequality by Lagrange mean value theorem. There will be nowhere they use Maclaurin's formula to prove this inequality. So since it is Maclaurin's formula is derived from Lagrange mean value theorem, so by Lagrange mean value theorem we can prove this type of inequality, and this type of inequality is very important for your exam. So how you in this way we can calculate the inequality very easily. Thank you.